Okay, quickly I'm doing a recap. See here, in AC currents, we are speaking, when we speak about DC current, what is a DC current? DC and AC current. What is DC current? Direct
current and alternating current.
Very good. Direct current and alternating current. Direct current means all the electrons or charges are moving in a straight line. Whereas in alternating current, charges are oscillating towards its mean position and energy is being propagated. Okay, charges are moving about its mean position. That happens in AC current. When we speak about AC current here, we are speaking not about the wall outlet. Okay, the wall outlet has a fixed voltage and fixed frequency, like 230 volts AC and 50 to 60 hertz. Okay, there's a fixed value. But what we are speaking here is about the oscillator or frequency generator. Means what happens when we take the output, it's like a sine wave or it's like a cos wave or any type of wave. Okay, where you can increase the frequency, you can change the time period also. You can increase the frequency or change the frequency, or you can change the time period. That is in our control. Okay, and it is when you touch the wire, you won't get any shock for frequency generator. I'm not speaking about the alternating current which is coming from the wall outlet. Is that clear? This is the first thing you should keep clear. Okay, then only you will understand what is this, why it is required, why AC these circuits, oscillators and frequency generator got very much importance, because there is no electronic device without an oscillator. There is no electronic device, right from your computer, your laptop, your mobile phone, your tablet, everything needs a clock. That clock works on a frequency generator. Okay, for that there is an IC fitted in every electronic device. Clear? So that is why this lesson is very, very important to understand. Why? Because if the clock is not perfect or the frequency is not perfect, then the speed of your laptop or speed of your computer or your phone or everything depends upon the oscillator frequency. The more the frequency, more will be the speed of your the laptop. So that is why whenever you purchase any when you see the processor speed, like especially for laptops, it is 2.2 gigahertz. You might have heard this. 2.2, like example,
yes,
not 2. Then it will be 2.2 gigahertz. The computer students can understand. What is the meaning of 2.2 gigahertz? It is 2.2 into 10 to the power of how much? 9 hertz. Okay. So this is what? This is the frequency. This is the frequency. What is the relation between frequency and time period? I will switch off this. Are you able to see the board properly?
Yes, sir, we are able to see.
Now is it okay better? Now is it better or before it was better?
So both are almost the same.
Same, okay, no problem.
This is good.
So we have time period is equal to what? 1 by frequency. That will be equal to 1 by 2.2 into 10 to the power of 9. But when you solve it, it will become 0 point something, like 1.2 means 0.5 approximately into 10 to the power of minus 9 seconds. Means what? This much nanoseconds, 0.5 nanosecond means to solve one instruction, to execute or to compile one instruction or of a program, it will take how much time? 0.5 nanosecond. Means the speed is the more the speed of the more the frequency of your oscillator, less will be the time of solving the problem, less will be the time of solving the instruction. So whenever you buy any electronic device like laptop or mobile phone or your tablet, you have to look at the frequency of the oscillator. If it is very high, that means definitely your speed of the laptop will be very good. Understood now? Is that clear? So that is what we are going to discuss. So then what we discussed, what we are going to discuss now, we started with 3 components. What are they? Resistor, capacitor, and inductor. These are the 3 components what we have studied about today. That is 3 circuits. Okay, then we have LCR circuit. Now in okay, so before that we started with phase. What is phase? Phase is
the leading or lagging of a wave.
No, not this, not leading. Phase means phase angle. It describes what? It describes the state of motion and direction of a particle. It describes the state of motion and direction of a particle. Clear? Or angle made with its initial position is known as phase. Then after that we have, it is measured in what? Phase is measured in phase measured in the units of phase. Radians, not radians. Okay, it is radians. When we write RAD, but it's measured in radians. We can measure in degrees also. But physics, any problem when you're solving, even if it gives in degrees, you are going to write in radians. You are going to convert that into radians and solve the problem, whether it is rotational motion, whether it is electricity, or whatever it is. Now, now, next is phasor diagram. What is a phasor diagram? Anyone? What is a phasor diagram? Representation of a wave on a circle. Representation of a wave on a circle is known as phasor diagram. What happens when this is going up, it will move on the circle. Understood now? When it is moving like this, the particle will be moving on the circle. Understood now? So that is said to be a phasor diagram. Now, after that, we have in phase, out of phase, and constant phase difference. What is in phase? What is in phase?
When phase angle is 0.
Very good. Phase angle is 0. Can you give me one example for in phase?
The soldiers marching.
Yeah, very good. Perfect. Soldiers marching. They are perfectly in phase. Okay. Now, what is out of phase?
When the angle is
The phase angle is 180.
Yeah, very good. If the phase angle is 180 degrees, that is out of phase. Can you give me one example for out of phase? Yes. Can you give me one example? Yes, Ashas. Yeah. Where is Ashas left? Are you there, Ashas? I don't know. I slept, I think. Huh? Okay, so I give one example, right? Yeah, like suppose you want to go outside and you requested your dad or your mother, then immediately they scolded at you and they made you to sit for study. Okay, so what happened? You were in a good phase. Then suddenly you came in the opposite phase. That is like 180-degree phase. Okay, so out of phase. And constant phase difference means? Constant phase difference means leading or lagging of a wave. Leading or lagging of a wave is said to be leading or lagging of a wave is what is said to be constant phase difference. Okay, that is known as constant phase difference. Okay. Now we started with resistor circuit. Okay, first circuit. What happened when we no?
Sir, can you please explain this again?
Which one? Which one? Where were you?
Sir, this one, this topic.
Resistor in AC, right?
No, sir, the phase difference.
Phase difference, we have in phase, out of phase, and constant phase difference. In phase means
okay, sir.
you know that, right?
Yeah, absolutely, sir. In phase, especially in phase.
In phase, out of phase, and constant phase difference, right?
Yes, sir.
So you went out of phase for 2 days, right? 2-3 days last week.
Yeah, sir.
Now,
But few people are in phase from quite a lot time.
Okay. Now we will go with the resistor circuit. The first is resistor circuit. What happens when we connect resistor in an AC? Okay, so when we connect a resistor in AC, what will happen? Then you have to apply Kirchhoff's second law there. What is Kirchhoff's first law and second law? Can anyone say?
So the junction
rule
and the loop rule.
Very good. What is the first rule?
The junction rule states that the number of charges towards that center is equal to the opposition of charges in the other direction, in the opposite direction.
Now, see here, the first law, it says that current coming to the junction is equal to current leaving the junction. Number one. Second one is what? Loop rule. Means the sum of potential differences in a circuit, in a closed circuit is 0. The sum of potential differences in a closed circuit is 0. Means what? The battery minus the whatever the component is there, voltage across that component. If you add it, it will become 0. So, in that we discussed about what did we come. What was the conclusion? We came at the conclusion that both voltage and current are in phase. There is no phase difference in when the resistor is connected in AC. That was the first one. Now after that we started with the inductor. Okay, what is a function of a resistor? Can anyone say about it?
To resist the flow of current and drive the flow of current.
Very good. It resists the flow of current or it drives voltage across the component. Okay, drives the voltage or potential difference across the component. Okay, to make you understand, I gave the example of the Spain Bull Festival. You know Spain Bull Festival? Have you seen anytime? Spain Bull Festival. In Spain Bull Festival,
Yes, sir.
Ashas, did you participate in that Spain Bull?
Sir, in what?
Spain Bull Festival. Did you ever see? What is that? Spain Bull
Bull
Festival.
Festival.
Have you seen Zindagi Na Milegi Dobara?
Yes.
In that there was the bull
I
running
understand, I
and
remember.
The
yeah,
last
that is
one.
the Spain Bull Festival.
The last.
Sir, ask Aaron, he got hit by many times in the ass
Huh?
by thorns.
What happened?
Yeah, sir. I have seen that Spain Bull Festival.
Like what happened? The person will be wearing a white shirt, white pant, and he'll be having a red scarf on his neck. Have you seen that?
Yes, sir.
So what is the what? So now
Should make HMM run in that. Wearing white sari and
There also she'll be like boys and girls alag.
देखो boys अलग बुल से खाएंगे और girls अलग बुल से.
No, listen. Now
On 2 different days.
okay, now listen, leave it. So here the purpose here is what we are speaking about, when
Purpose here is self-suicide. I mean suicide.
Stop it, sir.
So we have to drive. What we are trying is the.
Sir, have you heard about the Spain Tomato Festival?
Acha, okay. That we will do it. No, we will do it when you come here. Don't worry. When
Sure,
you
sir,
come
tomorrow.
Sir,
Should I
वो
bring,
स्पे करना है.
yeah, we will
सारे
bring-
टमाटोज उस पे ही
should I bring?
फेंकना है.
Ashad, you wear full white and come on set again.
Yeah.
Sure, bro.
So in that, what
Hey,
happens?
Aaron, bring 1 kilo tomatoes tomorrow. I'll bring 1 kilo tomatoes.
Raj, let's so speak.
Okay. So
Sir, और बुल तो हमारे पास है ही यार.
Sir, mute कर दो इसको. Option है आपका.
okay. Wait. Now let me complete this. Okay, let me complete this. Then later on,
Sure,
once I end the meeting, because recording is going on, so I need to. So we'll focus more on the teaching. Okay.
Sir, if you post this, you are talking about tomatoes and bulls.
It's not about. I'm giving an example. My intention was completely to see here. The purpose was to how you are driving how the bull is driven
Bull
towards
towards you?
the person. Okay, because of the
Okay.
red scarf, whatever you are wearing here. The same thing when you put a resistor. So what happens is it drives the voltage across itself. That's the purpose actually. It drives the
Nice
voltage.
example, sir.
This is a basic concept which is required for potential divider circuits, because they removed transistor part in your semiconductors. If at all the transistor part was there, because there were 3 circuits over there in transistor, that also they deleted. Otherwise, I would have explained how the potential divider works. Wow, what is the exact necessity of the potential divider? How the voltage is divided to so many parts. Suppose when you are using a laptop, now it is giving maybe 30 voltage DC. Okay, it is the adapter is converting 30 voltage DC. Now that because the motherboard requires maybe 4 volts, CD drive may be requiring 3 volts, hard disk may be requiring 2 volts. We don't know. But how it is divided, this is all done by potential divider. This is all done by a potential divider. Whom you want more, you keep more resistor. Where you want more, put more resistor. Where you want less, keep less resistor. So it will drive more voltage. Got it? Got my point? Understood? Is that clear now?
Yes, sir.
Yeah. So understood now? Okay. So this is about, the potential divider, but very important concept in electronics and electricity, potential divider concept. So anyways, so that is the reason they are asking us to teach all these things in the, actually that is very interesting lesson, but people made it very dry actually. They're more with the equations and all. So that's the first circuit. Second circuit was like AC voltage applied to an inductor. So what happened here is, so now here, so AC voltage applied to an inductor. What happened is, now in this circuit, what happened? What is the voltage across an inductor? Potential difference across an inductor. What is that? Can you tell me the equation? See, potential difference across resistor is IR. V is equal to IR. But what is the voltage across the inductor? Can anyone say that? Voltage across the inductor. Yesterday we did this. I'm going to repeat the same thing. L into di by dt. It is L into di by dt. The voltage across the inductor is given by L into di by dt. Then we solve that equation. At the end, we got XL. What is XL? What is XL?
Sir, XL.
It's the
Arham shirt size.
Inductive
inductive resistance
reactance. Inductive
or
reactance.
reactance. Sorry.
It is
Sorry.
inductive reactance. Okay. That is known as inductive reactance.
Yes.
Clear? Now, so what is the formula for XL? XL is equal to omega into L. XL is equal to omega into L. But what is again omega? Omega is said to be angular frequency or angular velocity. Omega formula is what? 2 pi nu or 2 pi by T. Is that clear? Omega formula is 2 pi nu or 2 pi by T. Is that clear? Is that clear? So we have XL is equal
Yes,
to
sir.
L and omega is equal to what? 2 pi nu or 2 pi by T. This is the formula for the angular frequency. Clear? Now, so AC voltage applied to an inductor. In that case, we came to know that the last when we solved the equation and all, we came to know that current lags the voltage by 90 degrees. Current is lagging and voltage is leading in this particular circuit. And you have seen this is the waveform. This is the waveform of the waveform, and this is the phasor diagram. This is the waveform. This is the phasor diagram. Okay, these are the two of them. Next, we have what happened when A to B. Like suppose if I am taking one wave here, like one wave pulse or one wave, then like I divide into 4 parts: A, B, C, D. A to B is a quarter cycle. B to C is again a quarter cycle. C to D third quarter cycle. D to E fourth quarter cycle. So A to B, what happened? The voltage current will become 0 to max, 0 to maximum. Okay, so current is becoming from 0 to maximum. Now A to 0 in the first quarter, and polarity will be positive. Energy is absorbed in that case. What is the purpose of an inductor? Function of an inductor? To store magnetic energy. To store magnetic energy in the form of magnetic field. Is that clear? To store magnetic energy in the form of magnetic field. That is said to be what? That happens in the inductor. Now, so in the first case, in the first quarter, it magnetizes. Then B to C, what happens? Maximum to 0, and polarity will be negative, and energy will return, and it is demagnetized. Third case, what happens? 0 to minimum, it will become positive again, and energy is absorbed, and again it becomes magnetized, but in the opposite direction. Fourth case, from D to E, from here to here, what happens? Minimum to 0, it becomes polarity is negative, energy is returned. Okay, there is energy is returned, then it is demagnetized. These are the 4. Now we will go to capacitor and AC. Okay, then we can go for LCR. Is this clear, all of you?
Yes, sir. But in our school, like for the phasor diagram, they applied the value for that omega T, like 90 degree, 180 degree, 270 degree.
Yeah,
60 degree.
you mean
Like that, they applied the values.
Yeah, you mean like suppose for inductor it is like this, right? This is the voltage, right? This is your voltage,
Yes, sir.
voltage thing. Okay, and this is the phasor diagram, right? This is your phasor diagram.
Yes, sir.
Now what happened? See, I will just tell you. Suppose if you are starting the voltage is here, but current started from here, right? Okay, current, see, is it not? Current started from here.
Yes, sir.
Yeah. So what is the angle difference now? Current is here. Maybe sorry, I took a big circle. Okay, but I'll just reduce the size of the circle. Okay, now it is perfect. Okay, so if you see here, it will be here. See, this point is here and this is here. Is it not? So if you see carefully,
Yes,
how much
sir.
is the angle now? 90 degrees. Is it not? This is what they explained.
Yes, sir.
Yeah, that's it. It's the same. Is that clear?
Yes, sir.
Okay, perfect. So this is about the inductor. Now the angle is 90 degrees. Suppose if the voltage is, when the voltage was here, current was here. So angle was 90 degrees. Okay. Now we will go for with the next circuit. Okay. Next circuit is what? The capacitor side. Voltage
Yes,
across a capacitor.
oh, okay.
Now, here we will discuss about AC voltage applied across a capacitor. So here we have AC, and then we have a capacitor like this. C is the capacitor, and here this is the voltage. E is the voltage. Now, what is the formula? We start with the same voltage. V is equal to what? Vm sin omega t. V is equal to Vm sin omega t. Vm sin omega t. So we have what? This is the first one. And we know V is equal to what? V is equal to Q by C, the voltage across the capacitor. The voltage across the capacitor is given by what? V is equal to Q by C. So because C is equal to QB, C is equal to Q by V, or C is equal to Q by V. This is a formula for capacitor, right? When you go back to the second chapter, C is equal to Q by V. So we cross multiplied that, we got this equation. Now the voltage across this should be equal to voltage across this, is it not? Voltage across the source is equal to voltage across the capacitor. So we write here Vm sin omega t equal to what? Q by C. Vm sin omega t equal to what? Q by C. So now here we have formula. What is it? I is equal to what? I is equal to dq by dt. That is rate of flow of current. Rate of flow of charges. Rate of flow of charges is current. I is equal to dq by dt. Clear? I equal to dq by dt. Now next one is what? We have I is equal to what? I is equal to d by dt. D by dt of what? What is Q? Q is equal to what? Vm sin omega t. Vm sin omega t. So I is equal to what? Vm into d by dt of sin omega t. Sin omega t. Here I is equal to what? Vm into sin, derivative is what? What is the derivative of sin? What is the derivative of sin? Derivative of sin
The
is what?
derivative of sin omega t is cos omega.
Cos omega t. Derivative of omega t is omega. Derivative of omega t is omega.
Omega.
Okay, so we got this value. I is equal to what? And now I is equal to dq by dt, right? Yeah, I is equal to dq by dt. So once again, let me see. Yeah, I is equal to dq by dt. Q is equal to CV right here. So the formula here is Q is equal to CV, C into V. So C should be there here. Okay, I'll write here I is equal to CV, C into the whole thing. This is also again I is equal to C into V. Again here also I is equal to C into Vm. Okay, C into Vm cos omega t. Now because see again I started with sine, I got cos. I cannot compare sine with cos function. When both are in the same, see how can I compare like physics marks with commerce mark or accountancy mark? I cannot compare. Is it not? I cannot compare
Yes, sir.
mathematics mark with some other subject. I cannot come. That's not possible. So the same way, when this is in one, the input is in sine and the output is in cos. I cannot compare like that. I have to convert that cos into sine. Then only it is possible. So what I am going to do now? Cos omega t is equal to sine of omega t plus pi by 2. Sine of omega t plus pi by 2. Now here what is that? I is equal to what? Im. I is equal to Im. Then sine omega t plus sine omega t plus pi by 2. Okay. I is equal to Im sine omega t plus pi by 2. Okay. So now what is Im? Im is equal to what? C into Vm into omega. Okay. C into Vm into omega. Now Im is equal to what? Im can also be written as Vm by 1 by omega c. See, can we write like this? Im is equal to Vm by 1 by omega c. Can I write like this? Yes. Can I write like that? 1 by omega c. Yes or no? Yeah. See, when I simplify again, this omega c will go back to the numerator.
Yes, sir.
Is that clear? Now,
Yes, sir.
so I am writing here Im is equal to what? Im equal to omega by xc. Sorry, Vm by xc. Clear? Im
Yes,
is
sir.
equal to Vm by xc. Clear? But what is xc? Xc is equal to 1 by omega c. Xc is equal to 1 by omega c. Xc is what? Xc is capacitive reactance. Xc is capacitive reactance. Clear? Xc is said to be capacitive reactance. Now, so here it is the units of Xc is ohms. Okay, units of Xc is ohms, and it is directly inversely proportional to the frequency. Xc is inversely proportional to the frequency. Well, how come? How it came in that way? Because we know that omega is equal to what? Xc is equal to omega. Omega is equal to like 2 pi nu, or we can also write 2 pi by t. 2 pi nu or 2 pi by t. This is the formula for omega. Because it is in denominator, so that's why it went in that way. Means what? This graph again, there is a graph here. That is what frequency versus the reactance. So when they drew the graph, the graph is like this. Again, this graph is not there in the book, but they are asking question based on this graph. Again, only this relation is there in our lesson, but this graph is not there in the lesson. They are asking still questions on this particular graph. Okay, so current leads voltage by how much? Here, current leads voltage by 90 degrees. Okay, current leads voltage by 90 degrees. Is that clear? So here, so so this is what we have to discuss here in this equation. Clear with you all? And now we will discuss about the waveform also, about this, how the waveform is. So if you draw the phasor diagram for this, okay. So what happens here? Current is leading or lagging? This is the voltage. But here current is, yes, current is leading. Okay, this is current and this is the voltage. So current is leading voltage by 90 degrees. Okay, 90 degrees or pi by 2. 90 degrees or pi by 2. Is that clear? Current is leading voltage by 90 degrees. So if you draw the phasor diagram, again, if you ask me to draw the phasor diagram, how it is? This is the voltage and this is the current. Current is here. Okay, current is leading voltage by 90 degrees. Understood now? Is it clear? Is that clear? Yes or no?
Yes, sir.
Okay,
Yes, sir.
please copy this carefully.